Every year we celebrate the National Science Day in India at the end of February to commemorate a very special landmark in the history of Indian science. A lot has happened in Indian science over the ages, but in the 20th century, one of the most important events that happened was the discovery of the Raman effect by C.V. Raman in Calcutta, at the Indian Association for Cultivation of Science. It was a very important event for many reasons. One is C.V. Raman himself was not a scientist by profession for a long period of his life. He was an accountant, and he pursued physics as an interest. And an Indian institution of science was so liberal at that time in the 1910s and 1920s that they gave him the chance of performing his wonderful ideas for experiments in the evening after work in their laboratories. I think current laboratories have a lot to learn from this kind of an approach. During these experiments, C.V. Raman discovered the Raman effect, characterized it, explained it, and also went on to do some very important pieces of work. This Science Day itself commemorates the day on which the Raman effect paper was accepted for publication. And this led to a new confidence in Indian science because that led to a Nobel Prize in physics, the first to be won by an Indian working in India. As I said, this event itself has many, many different connotations which serve as a lesson for us in contemporary India, where we are learning to be self-reliant. We are trying to lead the world in many scientific endeavors, and we are also trying to show the general public and the young people studying in India that science is a wonderful place to go in their careers, and it is possible to study in India, to do research in India, and still lead the world. C.V. Raman was an accountant general, part of the accountancy service of the Indian government. He managed to do world-breaking science by sheer hard work, working in his spare time. This gives the message that science is possible with hard work, science is possible against all adversity, and science needs to be one of the major things that everybody, all people, not just scientists working in labs, need to work on, need to know about, and science has to reach everybody. So National Science Day has this mandate. It brings the science. National Science Day has this mandate. It brings the science out of the research laboratories and the universities to the common person in the street. It talks about, it shows how science is done. It shows how Indian science is done. And it inspires Indian scientists to talk to the general public, to school students, to school teachers, and tell them about the current advances that are happening in science. It talks about how science is done in the whole world, and it talks about how Indians have done science in history. In IUCAA, we picked up this theme in the early 1990s, in the early years of IUCAA. And for about 30 years or so, we have been celebrating National Science Day in order to take our science out to the public, in order to show young people how a career in science is possible, how science improves our lives in every way. When we started doing this, not many research laboratories or universities did this. National Science Day used to be celebrated by the government, but not by many scientists. I'm very happy to say that after this path-breaking work that IUCAA had done in the 1990s, nowadays a lot of scientific institutions take part in Science Day activities, and we see that on Science Day, the general public has also got into get into festive mode on National Science Day like any other festival, and they go and visit scientific institutions because they know that they will be welcome there. This is the message of the National Science Day.
Hello, my name is Dibarati Chatterjee. I am an associate professor at the Inter-University Center for Astronomy and Astrophysics in Pune. Welcome to IUCAA. What are we discussing today? We are talking about what is science. So what do you think is science? The word science comes from the Latin word scientia, which means to know. So what is it that we want to know? Practically everything around us. How are things happening when they are happening? Why do things work? When we look up to the sky, we see the stars, the sun, the planets moving. We ask ourselves, where did we come from? Where are we going? Science helps us decode the secrets of the universe. So science is nothing but the art of acquiring and sharing knowledge in a systematic way. So what do I mean by a systematic way? I mean by asking questions and trying to answer them in a logical and consistent way. So why do we do science at all? It's because by analyzing our past and our present, science gives us the power to predict the future. Let's take an example. Newton, Einstein, Galileo, they put forward the theory of gravity. So the theory of gravity not only helps us to understand the motion of cosmic objects in the universe, but it also helps us navigate our cars with the help of GPS on our phones. From historical times, we have been passing down knowledge from generation to generation. Nowadays, science is carried out in research institutes like IUCAA, at universities, in laboratories. But is science only restricted to laboratories? Science is all around us. So let us question the things around us, try to find the answers with the help of science. Stay curious, and most of all, keep calm and do science. Thank you.
What do you think when you hear the word science? Lab coats and microscope, telescopes and stars, an astronomer peering through a telescope. While these things reflect various aspects of science, none of these provide a full picture. Science as a field is multifaceted. Science is a way to gain knowledge about how and why things happen the way they do by observing the world and designing experiments. In return, this knowledge is useful for all sorts of things, from manufacturing a toothbrush, paste, oil, cars, bridges, to prompting people to hand wash during a flu season like the one ongoing pandemic. Scientific knowledge allows us to develop new technology and solve practical problems. The process of science starts with a question. Scientists observe the world around them and ask, what is this? How does this work? To find the answer of these questions, they design a system of experiment and observations. For example, we know a lot about our universe via scientific observation, such as the sun is 300,000 times heavier than the earth, and some meteors can travel as fast as 44 miles per second. Science is a collective work. Scientists do experiments and observations and record their findings, such that other scientists can verify and use these findings to arrive new results. There are many subjects in science. In particular, physical science include physics, chemistry, astronomy, etc. And life science, which deals with living things, include botany, zoology, paleontology, etc. If someone asks me to define science in a single line, I would say that science is a systematic and well organized study of a subject.
What we mean by scientific temper is to try and make sense of the world around us and the universe using the scientific method. What scientific method means is to test our ideas based against the current scientific data as well as the research that has happened. So what that also means is that personally we may have our favorite ideas about how things work, but if they don't match with what fact suggests, then that's a wrong idea. And alternatively, we may have an idea that we don't like, but if all the scientific facts that we know of matches that idea, then we have to accept that that's the way the world works. I'll give two examples of how it works. One is regarding the eclipses. For thousands of years, people believed that eclipses were caused by Rahu and Ketu. These were like monsters who would eat up sun, right? And over the last 100 years, and some people before that as well suggested that maybe it's not because of anything supernatural like that, but maybe because of the motion of Earth, Moon, and Sun, because of gravitational force. And all scientific evidence that we have come up against suggests that that is the reality, as in eclipses are just a common consequence of the motion of the Earth, Moon, and Sun system, and they move around each other because of laws of gravitation. So that's now a scientific fact which we have to accept, and even though we may like the idea of Rahu and Ketu personally. Other example would be, people often think that people of different regions or cultures or gender or ethnicity are different from each other at a biological level. Now, a scientific person would try and see whether if we conduct research, is there any truth to that? So over the last many decades, scientists have tried to understand if at a biological level there is any difference between people from different regions of the world. And all research that we have done suggests that there is absolutely no difference between one kind of people from the other in the world. In fact, all of us are descendants of one common ancestor in Africa some 100,000 of years ago. So even though personally I may like to believe that people are different based on their external appearances, but if I follow scientific temper, I'll keep my bias aside and just accept the fact that we are all same as humans and implement that as part of my daily worldview about how the world is. Like, all humans are same. There's no difference internally. There may be only external differences.
Scientific temper is as basic as asking a question. Think of a situation when your teacher is teaching you a concept and you don't understand it. Is then to say, ma'am, I didn't understand the concept, and acknowledge the limitation of your knowledge base and a gap in the workflow of the concepts the teacher is teaching you. Scientific temper at its very base, at its very core, is just to remain curious about anything, about your environment, about any concept which you don't understand, and acknowledge the limitation in your belief system, and to explore new connections and possibilities which you are not aware of. Is to say that there are things in the universe, the mysteries to the universe which you don't know of. Is to discuss with your friends, go to the internet, read more books, and try to dive deeper into the knowledge base. It's not only just your limitations, but think of a limitation which everyone is carrying with themselves, and together you have a knowledge base, but it's limited. There is an edge to it, and scientific discovery would mean pushing the boundaries of this edge further out, and you know, it's the collective curious of the whole group which can together push it beyond a point.
So today I am going to talk about scientific temper. Before I start about scientific temper, I'd first talk about scientific method. Okay, since last 400 years, science has made immense amount of progress by scientific method, which was the birth of modern science. Scientific method is about discovering truth about nature, and often we have learnt that truth is usually hidden, and one has to go through a complicated process of first looking at an object, so observing a phenomena, and then thinking deeply about it, and then figuring out under what rule this phenomena might be operating, and then again testing it empirically. So it goes through several processes. It goes through a hypothesis in which you think about some observed phenomena, as well as testing it empirically. So empirical testing as well as logical progress is a key aspect of scientific method. And because of scientific method, we have discovered so many laws of nature, which has really broadened our understanding of the universe, as well as utilizing these laws has actually helped us in day-to-day life. For example, a lot of biomedical applications, then sending weather satellites to rotate around Earth using laws of gravity has actually helped us in figuring out the weather pattern, in doing the forecast, in treating several diseases like cancer and stuff. So scientific method is very important, and scientific temper has to do with not only figuring out laws of nature in a deep sense, but also utilizing it in our day-to-day life. So scientific temper is almost scientific method, but in day-to-day life. I'll give an example. For example, sometimes there is a myth that people would say if a cat crosses your path, then something bad will happen to you, and so you have to stop there. And this is a concept which I think fairly a lot of people have in their mind, definitely in India, and nobody verifies it, nobody knows what was the source of it. And when I was a kid, I used to be curious about it. My parents never believed in it, so I used to ask them, why do other people believe in it? And they said, figure it out if it's really bad or not. So every time a cat crossed my path, I would keep walking without stopping, and after several times I saw it's random and nothing really happens to it. So empirically verifying a fact is very, very important. But even before that, a key principle of scientific temper is to be skeptical. Somebody tells you a fact, somebody tells you something which you don't know whether it's a fact or not. The first thing is to be skeptical about it. And being skeptical doesn't mean being pessimistic. You may still be optimistic or excited about it, but you have to be skeptical. You have to first understand that this could be a rumor, it could be a myth, and then go ahead and test it first and check if evidences suggest this or not. If they don't, then it turns out to be a myth. So such a scientific temper actually would lead to a much more healthier lifestyle, where you will not be fooled so easily about anything. Either it is a fact about nature, or it is something that affects your day-to-day life. Like somebody might tell you that you are not getting a job because of some planet rotating around sun has some effects on you, and then you may you may wear some gemstones or rings and think, okay, all this bad principle might go away. But you can test it. A scientific temper is to skeptically understand that every planet is made up of really mud and gas and stuff. So if a mud and gas could really affect everybody's life in a very different way, then there should be evidences of it. We could conduct a statistical survey in which we could see if this can happen. In fact, you can check it in your own life, and you can figure out that what really leads you to success. Is it the influence of heavenly bodies, or is it your hard work and other random factors which are involved? So scientific temper is very, very important, and given that we are in the modern era of 21st century, this is high time that we really bring scientific temper not just in the scientific community with scientists, but to our home, to everybody in our home, who look at all these myths in a skeptical way and figure out what exactly is the truth. This will lead to a much better lifestyle, and not only as fundamentally as thinkers, since we are all thinkers, but also living the life as practical human beings. Thank you.
this is about importance of scientific temper. I truly believe that if one grasps the definition of scientific temper, one would naturally find why it is very important. It's all there in the definition. And there can be many ways to put it. One easy way is that the scientific temper simply involves to be a seeker. We all want to be a seeker, which naturally arises out of curiosity. We just want to know things, and that is good enough reason to pursue that particular problem of your interest. There can be many things in the vicinity of yours, and you might be particularly focusing on some one object or one idea, and you want to just pursue that one thought, one single thought. But it's about how you pursue that will make all the difference. Lot of knowledge is there. It's also, by the way, very important to realize the difference between the information and knowledge, right. This is the era of information era, in which you simply Google something and you have all the information you might need. Is that enough? Scientific temper does not involve merely collecting data or merely collecting information from one source to another. It is going many more steps ahead of that information and to acquire the necessary knowledge to really grasp what it is to know something. Knowing is a very different process. And why do you want to know? Yeah? It's something that you have to answer yourself. You are curious, you are interested, and therefore you are doing it. This is good enough reason to do science, to pursue a thought. And if you can't really rush yourself into this, right. So, take for example, one example like of a sunspot. How did we come to know about sunspots and its properties? And simply look at the timeline, just as an example that what went on, how it evolved and everything. Already in the 17th century, in the times of Galileo, and there was a contemporary, there were the fierce fighters, they were Christoph Scheiner. These were the two people in Europe. They basically built their telescopes, observed the sun, and then they found that there are dark spots, dark features on the sun. They simply pursued this and came to know about these features on the sun. They made some excellent hand-drawn drawings, and that is about like how carefully and how minutely you observe something, how much deep you want to get into this, right. So, they focused, and unbelievably for like many solar cycles, like one solar cycle is like 11 years, couple of solar cycle will make it like 30 years of painstaking daily observation of the solar disk, making sketches of the solar disk, hand drawn sketches. These are all available on the net now, you can find. But these were not known as some magnetic features. It's only as an urge to know more and more and more about what these spots are. Simple questions like what is this spot has led us to now know, after so many centuries, that these are the magnetic features on the sun. Most powerful incidents that occur in the interplanetary space between the earth and the sun basically are all powered by these sunspots. These are the spots that are the root cause of these very extreme high energy events that also affect our terrestrial life and basically controls our space weather. This is all coming from that one or these sunspots, which were basically observed by two curious people, a few curious people already in the 17th century, right. And it's only a systematic further development and observation of that one particular thing has led us to so much knowledge. You can all read about it, but is that enough? So, to know more about it, you have to basically go further, you go do your own research and inquiry. It all also starts by doubting your previous readings and writings. So, you simply go and doubt. Unless you have yourself grasped it and known, that particular piece of information may not be of any use to you. You have to actually do it yourself to know what it means to be knowing. Okay. So, and that is what makes it very important. One might get confused in the process that for example, lot of people nowadays you can think that you may try to relate it with humanity or something, if whatever I am doing and pursuing has any relevance for humanity. So, questions like these can come, you simply ignore these questions in my opinion, because the goal is to simply seek, and as a result whatever knowledge will come, it will benefit the humanity and society. It is just like a flower. Flower does not bother whether somebody is smelling it or not, or somebody is really enjoying its fragrance or not. Flower is simply blooming, and it is good enough a view. So, that way each individual who is pursuing some activity or some thought, that knowledge whatever it will bring, it will in a way bloom like a flower's fragrance. It will be there in the air, and that is so much comforting. After all, you asked a question, just like you feed your body with food, these answers that you ultimately come up with will also feed your soul, and that is good enough reason to pursue it. So, scientific temper, one important thing to note I believe is that one does not have to be a scientist to have a scientific temper. For all you know, you may naturally be having some scientific temper. To some extent every human being, and I can't speak for animals, every human being is duty bound to think. You can just observe a child and you simply see what the child is doing and how the child is reacting to its surrounding, to everything. It is simply questioning, and that curiosity is making the child go berserk, is basically trying to do so many things in such short time, because it is simply curious and bewildered by the nature and its variety. If you can keep this one fact alive, at some level remain child, you will definitely have a scientific temper. One does not require anything, it comes naturally. It is like it is part of your hardware, is there. Okay. So, that is one thing to note, and keeping it alive may be a struggle in modern times, but so long as you are like a child in some state, and it is a way of life by the way. Yeah? There is no office hour for having a scientific temper. It is a way of life. If you simply are an individual who likes to observe things a little more keenly and are simply asking questions, even if there is somebody giving you an answer, you simply doubt that answer, because so long as you are unsatisfied, you should keep on doubting and questioning, right. So, it is also a state of being in an unsettled state, when you are not settled. That is also a state you can call a person having a good scientific temper.